Number 12, discuss the concavity of the function f of x equals x squared minus 4 to the second power. Okay, concavity, we're going to have to jump to the second derivative. We already took the first derivative of this function in a previous problem, and that first derivative was 4x times x squared minus 4. So we just need to get the second derivative, and I would suggest before finding the next derivative to just distribute the 4x. So we're going to get 4x cubed minus 16x. All right, then from here we're going to take the second derivative, which will be 12x squared minus 16, and now we're going to set that derivative equal to 0 to find some critical numbers. So we got 12x squared equals 16. If I divide both sides by 12, that will reduce to 4/3. So I'm going to square root both parts. X equals plus or minus. The square root of 4 will be 2 over the square root of 3. If you kept it as the square root of 4/3, that's fine as well. So we're ready to do an F double prime chart. So we're going to put negative 2 over square root of 3 on it and 2 over square root of 3 on it. And then plugging things into F double prime, if I plug in a number, I'm going to say like negative 10 will be easiest. If I plug negative 10 into the second derivative, I will definitely get a positive number. If I plug 0 into the second derivative, I will get a negative number. And then if I plug positive 10 in, I will get a positive number. So when we want to discuss the concavity, I would say that f is concave up, wherever my second derivative is positive, which would be negative infinity to negative 2 over the square root of 3, and also again from 2 over square root of 3 to infinity. Our biggest thing on this one, again, I don't care how you leave and what form you leave that answer, and we do have to do our plus or minus because we're going to miss some zones if we don't. And that would be because f double prime is positive, okay, and then f is concave down from negative 2 over square root of 3 to positive 2 over square root of 3, and that is going to be because f double prime is negative. Okay, number 13, find the x-coordinate, if any, of each point of inflection. So points of inflection also come from the second derivative. So that's where we're going to head. The first derivative of 4 sine x is 4 cosine x plus 2x. The second derivative will be negative 4 sine x plus 2. I'm going to set that equal to 0. So negative 4 sine x plus 2 equals 0. Subtract 2 from both sides. I'm going to get negative 4 sine x equals negative 2. Divide by negative 4. I'm going to get sine x is equal to 1/2. And once again on this one, I'm going to draw myself a little unit circle. Sine, which is the y value, will be positive in the first quadrant and the second quadrant. And sine of x equaling 1/2 is again going to be my ring finger, so that will be at pi over 6. So some values of pi over 6. So in the first quadrant, it is just pi over 6, so that's one of my critical numbers. And then the second one, if I thought about this, pi would be 6 pi over 6, so a little bit before that would be 5 pi over 6. So those would be my two critical numbers. All right, so now doing my f double prime chart, we'll put both of those on it. Okay, before pi over 6, let's pick 0. So if I were to plug 0 into the second derivative, sine of 0 is 0 times negative 4 plus 2 is a positive number. Between pi over 6 and 5/6 pi would be pi over 2. The sine of pi over 2 is 1. 1 times negative 4 is negative 4 plus 2 is negative. And then 5 pi over 6, I could even pick pi. Sine of pi is 0. 0 times negative 4 is 0, plus 2 is a positive answer. So points of inflection would happen at pi over 6 and 5/6 pi, and that would be because f double prime changes sign, which means that's where it's going to change concavity. Okay, number 14, discuss the concavity of the function using calculus. F of x equals negative 5x squared, so concavity, again, we know we need to get to the second derivative. So f prime is equal to negative 10x, and f double prime is equal to negative 10. So looking for a critical number on this one. That is never going to equal 0. It's always going to equal negative 10. So if I go to do an f double prime chart, there's not a number to put in. So I always know that my answer is a negative 10, which is always a negative number, which means my function is always going to be concave down. So f will be concave down from negative infinity to infinity, and that is going to be because f double prime is always, in this case, negative. All right, problem 15. Find the x-coordinates, if any, of each point of inflection of the function. All right, so again, points of inflection, we have to get to the second derivative. I'm going to rewrite this to help us get this going a little bit easier. That would be x minus 3 to the negative 2. I'm actually going to make this u to the negative 2, so u will equal x minus 3, and du would equal 1. So taking the derivative, I'm going to get negative 2u times du. So in this case, it's going to be negative 2 x minus 3, whoops, to the negative 3 times du, which would be 1. And actually, I'm going to rewrite this. I'm just going to put this u back in because we have to do it one more time. So this is going to be 2u to the negative 3. And then if I take the derivative again, we're going to get 6u to the negative 4 times du again, which will be 1. So my derivative is going to be 6u to the negative 4, which is really 6 over x minus 3 to the 4th power. Okay, so then from here, we are going to figure out the critical numbers. The numerator will never equal 0, but the denominator will equal 0 when x equals 3. So make an f prime chart with 3 on it. And then I just noticed no matter what I plug in, when you take something to a 4th power, it will be positive. So on both sides, it's going to be positive. Points of inflection would be where the concavity changes. So f double prime would have to change signs, and it doesn't. So I'm going to say no points of inflection, because f double prime does not change sign. And there we have it.